Right, I just going over two little things in integration quickly because I saw plenty of you all got it wrong, right? All right, so before we go into volume, there's something I want to remember when you're integrating, right? If you have to integrate x squared, what will it be? Right? Add 1 to the power, divide by the new power plus c. Everybody okay with that? Suppose I start to integrate ax plus b all squared. What's the integral of this? Write back the ax plus b, add 1 to the power, divide by the new power and the differential of ax plus b, which is e. Okay? Right? What's the next option? What's the next option here? The next option is to expand it out. So if we can expand it out, remember you'll always get a squared, x squared, square this, and then what? Square this, then multiply these two and put a 2 in front. Ax by b is abx and then put 2 in front. All right? So the reason I show you this is that remember, when we rotate an object, let's say I gave you an object that looks like this. Right? If I take that line and curve and I rotate that 360 degrees, it will form a shape that looks like this. You're seeing that? So if I rotate this 306, like remember the one I showed with this straight line? If I rotate this line here, 360 degrees, well, what are we creating? Cylinder, right? So if I rotate this 360 degrees, I'll create a shape like this. What integration allows us to do is if we have these limits here, right? We could find the volume when rotated 360 degrees about the x-axis, your syllabus x-axis alone, right? By simply integrating whatever the function is between b and a, but here's a little difference, right? Integrating the function squared, right? And then with respect to x. And then you're multiplying it by pi. I think I gave you the formula already, huh? Right? So you're integrating between b and a, y squared, whatever function I'm giving you, you're squaring it, then you're integrating it. Okay? And then you multiply by pi after. All right? Copy it down. Let's go to an easy example. Right? To integrate, just remember, add 1 to the power and divide by any power. It's going to make you yeah. But it's not good. Yeah. Right? Anybody have tests on or they want to come and do some work or they come Monday, Wednesday, Friday, Saturday. I start there here. Holy, I don't know. Nothing happened.
No. I have my do the little session. So you're going to sit down there.
Right? So remember, we're gonna be integrating. All you have to do is add 1 to the power, divide by the new power. And then you plug in your values, right? Copy it down. We're gonna do a few examples. And that's it, because there's something real short. Then we start kinematics today one time. Anybody writing here? Hurry up here, please. You should show us in makeup. About where to. Huh?
Right, true. I'm very glad to solve. Stop.
No, man, too much.
So, yeah,
So fast. Right, time up. So let's take a look at this example here. All right. So watch here. Let's say I ask for the volume here, right? Let's say I ask for the volume here. I want to find the volume here. When I rotate y is equal to x squared plus 2, 360 degrees above the axis, right? And it will form the same shape, right? It will form the same shape. You don't have to draw it. I'm just showing you it will form the same shape, right? Ignore here and ignore here. Right? It'll form the same shape. We have to find the volume of that shape. To find the volume, we multiply by pi, the integral between what values? 3 and 1. And y is what? Y is x squared plus 2. We're going to square it and then integrate with respect to x. You okay with that? Yeah. So first thing first, you want to integrate it, right? You can add 1 to the power and move it on. It's up to you. Because it's just to the power 2, I am going to expand it out. So I'll get x to the 4th plus 4x squared plus 4. Please remember that we didn't integrate as yet. Square it, and I end up here. I'm now going to integrate, right? Whenever you integrate, remove the symbol. put a straight line. What's the integral here? Add 1 to the power, which is 5, divide by 5. What's the integral here? Add 1 to the power, divide by the, and what's the integral of 4? No, 4x. The integral of any constant is just putting on the x, right? Next step is what?
So,
Substitute 3, work it out. Substitute 1, work it out. That's okay? So that will be 3 to the power 5 all over 5. 4, 3 to the power 3 all over 3. Plus 4 to the power 3. Sorry, 4 by 3. And we minus in. And we minus in 1 to the power 5. 4 by 1 to the power of 3.
oh, wow,
Right? 110 in power is what? 110 in power is 1. Work it out now. Most times you will see leave your answer in terms of pi, right? Somewhere you get now. Work it out, tell me what you get. Right? What's the step? What's the steps again, right? What's the steps again? You plug in y, square it out, and then you integrate. Add 1 to the power, divide by the power, all the way down. Then plug in 3, work it out, plug in 1, work it out.
Yeah, make no.
It will be 3 to the 5, so it might be average now.
297.9.
When I multiply, right? What's the exact answer? Before I multiply by 5. A fraction? Then give you a fraction.
Yes. 136,600.
1,
136,600.
1, 5, pi. And remember it's volume, so you write units cubed. Yeah, that's okay. Forget it, 5. You can 5. But 5. Anybody else get up? 1366. Check and see now. Anybody online? Y'all got a value? 1366 and 15. No, maybe you do it wrong too.
Yeah,
How much you got?
10.51. What?
Yeah, how much you got? 1. What do you have? You get it? You get sure. Transfer again.
Okay.
Yeah, that's correct thing there, right? 1366 and 15 5. Yeah.
It's science 7.
This is 991.
Yeah, level up jadi lah. You
Yeah.
yeah, that was tadi solo.
No, it's our next thing.
Serious?
This might be a some best option.
Oh,
Keep it by
yeah, yeah, yeah.
What is that?
But it's just global. I think see what else have to see what I get.
That is a, but I'm not for sure the rest not.
Yeah.
And okay with that? Try a simple one. Find a volume rotated, find a volume. No, it's correct, correct. Find a volume rotated. What? You talking to me or you talking to Find a volume rotated between 2 and 1. Find a volume rotated between 2 and 1. When the function y is equal to the square root of x. When the function y is equal to the square root of x is rotated 360 degrees about the x-axis. Y is equal to the square root of x is rotated 360 degrees about the x-axis. Try that fast, you see one, right?
Yeah.
Well, when you square through that, this one is that.
That's okay. So y equals huh?
Now you didn't got it right.
Yeah. Even should be the idea since I said this green learning just
Right? When you square the square root, What you get?
Just here.
Yes, the x, right?
Yeah.
Then integrate in x.
That's how we got it.
Nah, that's me. That's me. That's only wrong answer. It's wrong. That's what any wrong answer.
It's the thing.
Online study answer, please. Make it
Yeah, I did that. I
Wait, right there. Sure. What's that one? Yeah. You want to
I remember that more special.
Oh, yeah. Okay, now, guys.
My now.
What? What? No, right. What did you say?
Right, leave the answer in terms of pi, right?
You get to see.
Which one?
Can you go on your
Hey,
Yeah, you might be. No, it's talking about.
Oh, yeah, you're right.
When you go, what's the thing always see? It's integrated.
Yeah.
Right. Let's try this one here, right? So this is pi. I'm not integrating us yet. When you square the square root, you'll get x. Right? And now we can plug in after we integrate the integral here, it's x squared on 2. X squared on 2, right? After you have x squared on 2, plug in your 2, that's 2 squared on 2 minus, plug in your 1, 1 squared on 2. So you'll end up with 4 on 2 is 2 minus a half. So I got 3 on 2 pi units cubed. Right? You don't have to leave it like this, huh? It's just normally people questions they say leave it in terms of pi. I like go again. Right, there aren't many of these, right? Chris, here said no answers. Nobody online said anything else yet? I will stop. Chris, you're done.
Take over. Yes. Mana ni dia orang. Orang dua dah macam. What?
Maybe you should be so far away. You know, you don't cast it. Yeah, you don't cast it. Hey,
Which one should you like?
what?
Name is from Trump.
No, my son. You're up. My son. My son.
Which one of my sons make Nah, you're crazy. That's the best I can do that. Wait, no.
Right, we are doing this question here. Calculate the volume when the area enclosed between x squared and 2 on the x-axis between 0 and 3 rotated. Right? If you don't want to write the whole thing, just write 2012 number 6 part D and just write the function alone. Right? But it's only topic by topic is 2012 number 6 part B. Sorry, D as in dog. You write the question, just write the function.
Before something. Yeah.
Oh yeah, try that there. X squared plus 2. You can time expand it out. Question said to leave the answer in terms of pi. We'll do one more of it and then put that on Facebook.
Let me see best. No, we. Hey, oh, everything is already.
Wait, properly, yeah.
Como es conocido hasta el usuario, sí. The only difference that you want to get
Oh yeah, some of the expanded by some of the expanded by
from the front of it, studios now.
oh yeah, 2 minutes lagi. Units Cuba.
I think that was sharper.
Online, can I get an answer, please?
Just read about it.
Sydney.
Sydney, Kalia, Caleb, all of the who online, send answers. Serena, Ethan. Right, I saw some mistakes with the expansion. Remember, whenever you're squaring something, it will be x squared plus 2 squared plus 2 by x squared by 2. Right, so I just put in 4 there, right? And then you plug in your values online and no answer out there.
So when I type in on WhatsApp, it's
Who's that typing on WhatsApp? Ethan, send the answer to me on Zoom, huh?
soon do I listen.
Right, so this will be x to the 5 on 5, the plus 4x plus 4x cubed on 3. And then you plug in your values. Plug in your values, you'll get 3 to the 5 on 5 plus 4 by 3 plus 4 by 3 cubed on 3 minus 0, right? You don't have to work on the last part. How much you all got?
483 and 558.
How much?
483.
483 on
5.
5.
Yeah.
One more for the road. Then I want to introduce Kinematics. Did we get any answers? Not an answer, not one answer online. Christopher, Sydney, Serena. Last one, 2018, number 6 part B. 2018, this one here. Why are you talking about?
No worries, I'll call back this.
Try that, please. Huh?
Yeah.
You can kind of expand this first. Want to see how you expand this.
Yeah, no, that'll be I just see. So that's it. Now this is actually fine. And then I see that you were probably the things of the body. They like to show you what
Yep, 4 and 0, yeah. Because it's first quadrant, the first value. Right, between 4 and 0. Take your time when you expand the NASA. That's a little bit harder than the normal expansion. Huh? Do it the long way. Right, do it the long way. Oh, yeah, expand it fast. Take your time when you expand. See how you expand, okay? It's a really long way, right? Really long way, you should end up with how many terms? 1, 3, 4, 5 terms?
No, it's one day.
You get 5 terms and then integrate it. 5 terms in the end.
This week, you know, one is a tax again. Yeah.
How much I can get? 7 to 6%.
Wow. I mean, what is 1919? Wait.
You can copy it, right?
Now you choose that.
Oh yeah.
You get 2, 2, 3, 9.
Give them money. See what is happening.
Right, so we just checking to make sure you multiply this thing out properly. X squared plus X plus 3 by X squared plus X plus 3. Right, X squared by X squared, X to the 4th, X squared by X squared by 3, that's 3X squared. X by X squared, X by X by 3. And last thing, last thing, 3 by x squared, 3 by x squared, 3 by x, and 3 by 3. Right? Then you bring your like terms together. X cubed plus x cubed, that's 2x cubed. 3x squared, 4x squared, 7x squared. 3x and 3x, 6x plus 9. Right? So now we're going to integrate that. We're going to integrate x to the 4th plus 2x cubed plus 7x squared plus 6x plus 9. Right? Usual steps when we integrating, add 1 to the power, divide by the new power. Right? Do the usual thing and then plug in your answers. Plug in your 4 and plug in your 0. Which one you like, Fishish?
Yeah, we can.
8. 55 or 15? 1 5. Hey, look, online answer something there.
Amazing.
Online send something. Great job, Serena. Oh, yeah, please remember, you could put this in the calculator and cross reference and make sure you get the same answer, right? Huh? Yeah, wait, the calculator. Right, that brings us to the end of that. Now we're doing kinematics. Kinematics time. Take a 2-minute break. Take a 2-minute break.
You can find add more to cheat the manual cheat the manual cheat now we are saying
It explains too long. I can pose that students.
Vedi, la facciamo, vedo io. Ok. All right, so our last application is kinematics. Let's talk. Right. So so kinematics is a little bit of physics, right? It shows the link between physics and macros. All right, I won't talk to you in 2 minutes, right? I don't know what's going on with online today.
so I don't know what's up.
Who, Ethan? Ethan, you not telling me anything? Leon, Caleb, and in fact, everybody except Serena.
So come see this balance.
Huh?
So come here. Nahi delete the message.
What you say? Tell me what you say. Ethan, I'm gonna remove you. I'm gonna put you anyway. Tell me, Ethan. In fact, Ethan, put on your video one thing. Put on the video there. Right, Bishish, 2 minutes up. Ethan, answer do something now.
Move volume now, hold on. Yeah.
All right, so head up kinematics. Last thing with integration and differentiation.
Video.
Right, set up kinematics. This is our last application, right? Since all the kid, you remember the differentiate?
Actually, important.
Or the kid differentiate?
No.
Or the kid remember the differentiate? Let me see, I can't control what she will get. This is, yes, addition, subtraction, multiplication, division. Look, addition, division.
I have an idea for my name. I'm just
Right. So here's what we're looking at, right? We're looking at something called kinematics. Right? Kinematics in our math involve 3 quantities only. The first quantity we call it displacement. Second quantity we call it velocity. And the third quantity we call it acceleration. All right? Anybody not doing physics? No? Never right? Okay, but I form all right. So we need to know about 3 quantities: displacement, velocity, and acceleration, right? And how do we relate it to each other in terms of integration and differentiation. So watch this here. if I ever ask you to find velocity and I give you an equation that represents displacement, all you have to do is differentiate displacement with respect to time. Whenever you differentiate this equation, you'll get this. That's your velocity, right? And then if you differentiate your velocity, if you differentiate this equation, you will end up with acceleration. What about if you go in this way? What you'll do? Rishish. If you want to go from here to here, what you'll do? You'll integrate A with respect to T. And here, you integrate V with respect to T. All right? So to go down, differentiate, up, integration. Right? There are some small notes I have to give you, so copy that down. Right? So you have to know about differentiation. You have to know the differentiate as well, right? Let's do a couple of examples to remember. Actually,
How do you know? I don't know.
I don't know what you can do about that.
Well, it doesn't really go that way. See, I don't know what it is. So,
No worry.
All right, so before we do anything, this is all we do in all. This is real simple, right? Let's say I said, Emily, I given you this. I given you 5t minus 4. And I want you to find an equation for v. What you will do? Integrate here. Right? So if I give you acceleration and I want to find velocity, integrate. Upwards integrate, downwards differentiate. So if I give you acceleration, just integrate this. 5t squared all over 2. That's okay? Add 1 to the power, divide by the new power. Integral of 4 is 4t. Everybody okay with that? Right? So now I am going to give you equations for each one and we have to find things. All right? But before I do that, just take this small note. Note that displacement. Anybody remember how to define displacement? Physics people. Changing. Displacement is what? Is it a scalar or a vector quantity? No. Right? So displacement is the straight line distance from start to finish. Displacement is the straight line distance from start to finish. Right, so wherever you start and wherever you finish, that straight line distance is called the displacement. Number 2, second thing to note that 2, velocity. Velocity is the rate of change of displacement. Right. I don't even have it. I have everything in this book. Note that number 3. Acceleration is the rate of change of velocity. Oh, sorry, I didn't give it the SI unit. Acceleration is the rate of change of velocity. The SI unit for displacement, meters, velocity, meters per second, acceleration, meters per second squared. All right. Next. What do you all think instantaneous rest means? Yeah. Yes, tough in, right? So write this down. Instantaneous rest implies that velocity is zero. Instantaneous rest. Okay, I got it. Instantaneous rest, instant and take. Implies that velocity is zero. Optic at rest, right? And last thing, initial. Last thing, initial. Initial, anything means that time is zero. Initial implies when time was zero. Initial implies when time was zero. Okay, so all these things are important when we go into a standard question like this. All right. Let's see if we can squeeze in 4. Right, well, can differentiate. All right. Just look back here and how to differentiate for those who don't remember. If I give you a 3t squared minus 4t plus 2, differentiation is the reverse. Multiply by the power, multiply by 2, write back the 3, minus 1 point power. So differentiation is multiplication and minusing. Right? What's the differential of 40 minus 40? Minus 4. What's the differential of 2? 0. Right? Stefan, do this mentally. Come on. 5 or 15? 15t squared. 15t squared minus 12t plus 4. Right? We need to remember how to differentiate, right? Because you don't know what direction they'll give it to you. Right? Somebody using mine yourself?
Checking the list.
Well, 6 or 7.
My God, so funny. I even the ice point. Ice point, the ice point. No, no.
Hey, where did I get it one from today? You can
The road, like, there.
There was a paper.
No, but if I see I would have no, don't.
Right, write this down. Given that acceleration is equal to, given that acceleration given that acceleration is 3t minus 4, given that acceleration is given by this 3t minus 4, find an expression for velocity. Find an expression for velocity given that when v is 2, t is 1. Find an expression for velocity given that when v is 2, t is 1. Find an expression for velocity. So the first thing you should ask yourself is, what equation do I have? What do we have? Acceleration. How do I get velocity if I have acceleration? Integrate. Go ahead, integrate it. And then see if you can figure out what you're gonna do with 2 on the 1. 2 on the 1, sir. 2 on. So, we got it there. Right, so we all recognize that we have to integrate, right? How much we got? Right, so whenever we integrate 3t minus 4, when you integrate this, you'll get 3t squared on 2 minus 4t plus c. What's the big problem here? The big problem is c. So they gave you this information to find c, right? Right? So when v is 2, you have to plug in t is 1. So when I plug in t is 1 in here, I'm supposed to get 2. Right? That's what the info here told us. And you work it out, you'll get 2 is equal to 3 on 2 minus 4 plus c. What you all got? 6, 5, 9, 9 on 2. Right? So your final answer is this. 3 on 2t squared minus 4t plus 9 on 2. Right? Kilan? Are you okay with that? Are you okay with that? Kila? Are you okay with that? Last one. Same thing, right? I'll give you the same things. Same question. Part 2 there. Same question, part 2. Part 1 was to find velocity. Part 2 is to find displacement. Find an expression for displacement. Find an expression for displacement find an expression for displacement given that S is equal to 10 meters when T is equal to 2 seconds. Find an expression for it. When S is 10 and T is 2. Right, I'll put a poll on the group on your level. Know what topic you want to start with you, right? You didn't do problem. That's going to be last one. Excellent. Quite
So you gotta make it.
we have find the equation. Right, Vishish. How do we get S? We have that equation for V. How do you get S? What to do? Integrate, right? So we're going to integrate that long thing there. 3 and 2 T squared, right? So we integrating 3 and 2 T squared minus 4T plus 9 on 2. Right, help know the integral here. Pishish, you, what's the integral of this? Right, over 3. What would happen 3 here earlier? Cancel off, right? What's the integral here? So just focus on integrating T squared. Right? Yeah. What's the integral of 4T? 4T squared on? What's the integral of 9 on 2? Right? 9 on 2T plus C. So when you simplify it, you will get T cube on 2 because these 3 will cancel. Minus 2T squared plus 9T on 2 plus C. That's all right? What's the last step? Last step, substitute. S is 10 and T is 2. Right? What do I have? I have 10, I have 4, I have 8, I have 9. Right? So I got C to be 23. No? I get 13. What shall I get? I get 23. What shall I get? Here. 5. Or this should be a plus. This should be a plus. This should be, yeah, sorry, I make a mistake. Right, so that's minus 4, 5, that should be. So your final equation is T cube on 2. All right. So we have some more this to do, and then we start revising probability and thing next week. Right, or they can squeeze in logs and whatever else they want, right? So we'll pick up some of those topics and start to revise. But are we doing properly?
Because see.
How many keep it up and that's it.
So I was
And the two, and the two. But I'm for good. I'm leaving it for good.
Yeah, there was some distance. But I'm on.
I don't online. Y'all didn't send, except for Serena.
Someone have.
Y'all didn't send me anything.